Inheritance is one of the main characteristics of the object-oriented paradigm, and it's maybe the reason why it's been so successful, so it's worth looking at these examples in some detail. Here we have a class BSc student that inherits from the class student that we defined before. We can also say that BSc student extends student, which is maybe closer to the reality of what it does. Anyway, whichever way you choose to say it, the way you write it in Python is this. That's your new class, and then you put a bracket after that and before the colon, and in between that's a class that's extended. You could also extend more than one class, but we're not going to go into the details of that. Right, so when BSc student is defined, we need to keep in mind that a BSc student kind of reuses all the machinery of the student class. So when we write a constructor for BSc student, we need to make sure that we have the data that we pass to it, all the data that's necessary to initialize a student object, and then any additional data that the BSc student class may require. So for instance, in this case, we want to pass the name and the surname, which were the data that we required to initialize an ordinary student. And then we have this new parameter likes beer that tells us something more about our student. And well, here we put a default value, which is, okay, if we don't specify that parameter, then it's true. And so how do we let the class student know about what the name and the surname of the student are? There is another keyword that comes to help here, and that's the word super. So super is the so-called superclass of BSc student. That's a class BSc student inherits from, and that's the class student in our case. So you see, we're calling the constructor of student with the name and the surname of the student. And if you scroll back up and have a look at the way we were initializing simple students above, you will notice that that's exactly the way we did it. So that's the way we used to do it. We just pass the name and surname to the student constructor. And then obviously we have this additional piece of information here, so we can store it in an attribute that will be peculiar to the class BSc student. We also define a new method here, havePint, that, well, behaves according to likes beer. And here's another example. We define a class PhD student that also inherits from student. So this time we take the name, the surname, and yet another parameter which is has published, and we assume in the beginning that is, we assume as a standard choice that is false unless the value is passed. And well, we call super, and again we pass the name and surname to the constructor of the student class. We then store the additional parameter inside an attribute of this class, and we write a couple of methods that make use of that particular attribute. Now, okay, let's run that cell, and as expected, nothing happens because we've just defined the class. When we move down here, what we are going to do is we're going to create or instantiate an instance of BSc student. We call him Ethan Owl, and he likes beer, which is not surprising with a name like that. And then we have a PhD student called Linotype, who surprisingly hasn't published yet. And we assign that to the variable nerd. Now we can call the methods of these two classes. So we can let the fresher have a pint, and we can make the nerd publish, and we can check the status. And let's go, and that works. And in fact, this code prints cheers mate, because likes beer is true. And since the node is published, then the status is as published. Now the fact that these method calls work is hardly surprising. I mean, after all, we've got these methods defined within the PhD student and the BSc student class, so this is nothing new. But the thing that's more interesting is that we can actually print the name of the fresher, we can buy print credit for the nerd, and we can check whether the nerd can print, and also, for instance, the university variable is inherited. If you try these things, they all work. Now this should surprise you a bit, because none of these things is defined directly in these two classes, so there is no attribute name being initialized anywhere for the BSc student. There is no print account being initialized for either of them. And there is no buy print credit method. Does not appear here, does not appear there. So where does that come from? That is inherited from the superclass. So that is defined in the student class, and the BSc student and PhD student are simply inheriting that code. Now, if you think that that isn't a big deal, just think that you have actually purchased the student class from some software vendor who sells a library for managing students in a university, and then you've customized that code to add a couple of student classes that are useful for you, that is the BSc student and the PhD student. Now, you may have no idea of the internal workings. In fact, you may have even no access to the internal workings of the class defined by the vendor, but you can extend it and customize it according to your needs. And this is a big deal. So for all aims and purposes, the BSc student instances and the PhD student instances, so fresher and nerd, they are in fact instances of student too. And you can check that with the isinstance operator here, which means that all operations that apply to the student class, which can be part, for instance, of this library that you've purchased. So the library that you got originally may have other classes for managing a register of students, for instance. So the question is, okay, but now you've modified the student class because you've extended it, and now you have a BSc student and a PhD student. So can that register still handle your classes, your fresher and your nerd? And the answer is yes, because for all purposes, fresher and nerd are students as much as they are BSc students and PhD students. And this is the magic of inheritance.